Here is Raj, and in this episode, we are talking about AI and healthcare, how AI is making difference in healthcare in nowadays, especially in this time of pandemic. Isn't it, Nikhil?
That's right, Raj and I are working on a really interesting venture that we hope will make a difference. There's a lot of science, or there will be a lot of science and math involved in this presentation today. As you can see, Raj has already tried to solve some of the scientific formula on his hoodie. Move that closer to the camera, Raj, so that everyone can see. It's too complicated. But Raj will go into more detail about that in this presentation.
Not for you, Nikhil. It's not complicated for you. I know that. So let's talk about. So what we are doing here, we are making healthcare more accessible for all remote and non-invasive diagnostic technology, which we are using a lot of AI in there.
So what Raj has on this slide is some illustrations of what a PPG wave is. Now, PPG is short for photoplethysmography, and the variations in that signal are synchronous with variations in blood volume underneath the skin. The way we extract that signal is we take advantage of the fact that your skin is translucent, which means that light can penetrate your skin. And light actually penetrates quite deep, especially green light. But it penetrates deep enough so that it's refracted back onto a camera at a different intensity. And that intensity varies depending on how much light is absorbed underneath the skin. So by measuring changes in pixel values within a video feed around specific areas on the face, we can extract this PPG signal. And I'll hand over to Raj now, who will go into a little bit more detail about the mathematics and the science behind some of the things we can derive from that PPG.
Thank you, Nikhil. That's where the magic happens. So we use those signals and we do the signal processing and short fast Fourier transform, all these maths behind it. I'll show you a little bit on that. So here is another algorithm what we use when we are cleaning those signals, because sometimes those PPG signals have some noise in there, because when we are recording those signals, there might be some motion movement, which we need to denoise it. So there is a way to remove some noise using this algorithm. We can remove some DC bias as well. Now you understand what is DC and AC is. I'll explain here in the next one. So what we can do as well, we can calculate the saturation rate, and these two components, AC component and DC component, are the vital part of it. As you can see in the formula, how they're being calculated. And oxygen saturation is, as you can see, the estimation of arterial saturation in oxygen, which represent the quantity of oxygenated hemoglobin in blood. And that is really, in normal human beings, it should be, healthy one should be around 98%, 95 to 98%, close to 100%. That's how I think the rate is. And a little bit more on, there is another AC and DC here going on for calculating this perfusion index unit, where if you can see this diagram here, you got the pulsatile arterial blood, non-pulsatile arterial blood, venous blood, and tissue. So that's how we calculate more information to calculate, putting into the formula and calculating those vitals. Next thing is important is heart rate unit. If you can see, like, we can always go for the peak to peak interval, and that's how we do it. And all these peak to peak interval we feed to the algorithm, and that's how we calculate those vitals, whether it is blood pressure or it is oxygen saturation rate or heart rate variability and those things. And now it's all like, you can see how we are presenting and packaging this all science behind this PPG signals into an app. And that's how I think, Nikhil, you're going to explain it on that.
Thanks, Raj. Yeah, so as Raj said, we are now going to show you something in action. So here is an application that we have developed. This is on my iPhone, and I'll show you exactly what's happening here. So at this point, I'm just about to look into the camera. As you can see, the camera has now locked on specific parts of my face, and in a second, it doesn't take more than 10 seconds to pick up my vitals. And there you go, we have it. And so I have instantly there a real-time feed of my heart rate, my respiration rate, and my oxygen saturation levels. All of these vitals are being derived from the PPG signal itself. And you can see that this mesh around my face represents small parts of the face that we are extracting the signals from. Some areas of the face, the skin is a lot thinner, so that would mean that the signal is more pronounced in those areas. But you can see here, I'm simply just using my iPhone to access some really important information about my physiology. And this is the power of combining computer vision, artificial intelligence, and signal processing. At this point here, I try to move, and you can see this mesh is still locked onto my face. So there's no escaping this mesh here. And that is the beauty of signal processing and computer vision. There you go. I try to move around a little bit. I am shaking my heart rate around, but as you could see, that was me simply looking into my camera. That is it, looking into my camera and extracting all of these vitals.
I mean, it's so awesome, Nikhil. That's what we are talking about at the beginning, how we can denoise those signals, and that's the way to do it using the mesh, so that we can identify those sensors on the change in the blood volume on the face, and then calculate the peaks correctly. That's where the accuracy of the algorithm lies, isn't it?
Exactly. And what you touched on earlier about calculating where the peaks are, that's an extremely hard problem, because in one of your slides, you show the motion artifacts that can happen in a PPG. And it's quite easy, even as a human, if I was looking at a PPG signal with some motion artifacts, maybe I would mistake one of those spikes as a peak. So it's really hard for an algorithm to know what's a true peak and false peak. And that's something that Raj and I have been working on very hard to be able to come up with a way to develop an intelligent algorithm that can distinguish between a true peak and a false peak.
Yeah, I mean, that's awesome, Nikhil. What a kind of the app which will make the difference to people's life,
Yeah.
and it's going to be really fabulous. And then I think the people are going to love it. So
Yeah.
guys, here is from Nikhil and me for this episode. And for more information on the Tech 2027, stay tuned. There you go.
Stay tuned. Raj and I will return back to orbit. We'll see you back on the International Space Station. Au revoir, my friends.
There you go. Cheers.